Token-based transactions are known for their high level of security. As a result of this, you no longer need to carry your physical card with you whenever you are visiting any merchant store. What they will do is they will retrieve the actual PAN number or a card number from their database and replace the PAN information basically in the ISO message. Hello everyone, welcome to the Domain Podium. Today I'm here to talk about transaction security through tokenization. In one of my previous videos, we talked about how you as a card holder can link your card to a wallet-based application like Apple Pay, Google Pay, Samsung Pay. And you can create a digital form of your card that can be stored securely in your mobile device. In today's session, we will deep dive into this topic and we'll try to understand how you can create that token, the digital form of your card for a transaction to make a payment at any of the point of sale terminal or a merchant. I'm your host Ramesh Chugh and I'm excited to walk you through this topic today. And before we move on, I would like to reiterate a few things from the previous session that we learned, which will help all of us to understand some of the basic fundamentals more effectively. So let's get started. First and foremost, I would like to talk about what is tokenization. I will repeat the same definition that I have used in my previous session. Tokenization is a process by which a primary account number or a card number, 16-digit or a 19-digit card number that gets printed on a physical card or a physical plastic. This sensitive information is replaced with a surrogate, a non-sensitive value called a token. So tokenization ultimately is a process through which we convert a sensitive information to a non-sensitive information. And this enables a card holder to use a token instead of a clear value of a card number at any of the physical terminal or a virtual terminal. What does it mean? Physical terminal means an ATM or a point of sale terminal, and e-commerce is an example of the virtual terminal. Essentially, there are three key players or actors responsible for making tokenization work. The first one is TRTSP, token requester TSP. Second one is TSP, token service provider, nothing but just card network. And third one is ITSP, issuer TSP. Could be a bank or financial institute. So I'll just briefly explain you what are these three players. TRTSP, token requester, that includes applications like Apple Pay, Google Pay, Samsung Pay, which enables a card holder to submit a request for a token provisioning. And with the help of a TSP and ITSP, a TRTSP can create a token against a card number. Ultimately, the token is created by the TSP, but who initiates that is the TRTSP, who initiates this request to create a token. And that token, once it is created, can be stored in that wallet, mobile application, which is securely stored in the mobile device. And then it can be used for tap and pay or e-commerce transaction. The second one is TSP, token service provider. That essentially refers to card network, card scheme, or interchange, whichever you want to call it. This middleman provides a range of services, for example, token creation, token storage, token to PAN mapping or PAN to token mapping, token lifecycle, etc. So once a TRTSP initiates a request that is received by the TSP, gets validated by the ITSP, and then finally token is created by the middleman, which is TSP. And last one is ITSP, issued token service provider. It is simply an entity that issues the card. This could be a bank or a financial institute, and the role of ITSP is to validate a card or a card holder during the token provisioning request, and once those validations are successfully done, sends a response back to TSP, which in response to these requests can generate a token and send it back to TRTSP that can be stored in your mobile device. And then you can, once the token is created, you can start utilizing it for tap and pay or e-commerce transaction. In addition to it, I would like to repeat the two forms of tokenizations. The first one is NFC or HCE, which is used in case of Android and iOS mobile applications, where the token is stored in the secure memory of the mobile device. And the second type of token is a card on file token, where a token is associated to a merchant's mobile application or website. I think one of the recent mandate in India has made card on file token very popular. However, in today's session, we will talk about tap and pay, and I might cover the card on file token in one of my subsequent videos. Before we begin to understand the tap and pay, I would again like to recommend watching the previous video. The URL is given in the comment section, and understand how token provisioning, device binding, token generation and activation is done. In order to understand the concept easily, I urge you to assume that you have any mobile device, could be an Android or iOS, and you have already gone through the journey of tokenization provisioning. What it means, like, you have already tokenized your card, and as a result of this, you no longer need to carry your physical card with you whenever you are visiting any merchant store. So please assume that now once the tokenization is done, means your card is tokenized in through TRTSP, TSP and ITSP, and now you are visiting any merchant store. Before you tap your mobile device on any of the point of sale terminal, as the user, first of all, you authenticate yourself either using biometric, a mobile pin or a pattern on your mobile device, right? Once you are authenticated, only after that your card number or a card image start appearing on your mobile device screen, and then you tap your mobile device on a point of sale terminal, right? So the moment you tap your device on the point of sale terminal, there are 2 or 3 things happens behind the scene, which we as a card holder or a user, we may not experience that. The first one is CDCVM, consumer device card holder verification method. A card holder can be verified 2 ways, as I just now said. The first one is you enter a predefined pin on a mobile application that can be validated by a TSP, whereas the second method is either biometric or a fixed pattern, which can be verified by the mobile application itself. The first one, which is a pin method, is not commonly used, whereas the second method is widely used, and no matter what method you have used, a CDCVM is basically passed on to the point of sale device the moment you tap your mobile device on the point of sale terminal. This is first thing that happens behind the scene, which you may not know as a user. The second vital verification is the cryptogram, which is generated by the wallet application, the TRTSP application. And in order to generate a cryptogram, there are certain keys that are exchanged between TRTSP and TSP. So this cryptogram is generated the moment you tap the you tap the mobile device, and it gets generated by the wallet application and gets transferred to the point of sale device, and later on this cryptogram is validated by the TSP only. The important point to remember here is, in none of these verifications, whether it is CDCVM or it is the cryptogram, issuer is nowhere involved. These 2 verifications are done between TRTSP and TSP. Third piece of information which is transferred to a point of sale device from a TRTSP is the token information. Because during the token provisioning, your digital form of your card was stored on the device, that is the token number, and that token number along with the CDCVM and cryptogram, these 3 information is transferred to the point of sale device. Once this information is received by a point of sale terminal, it initiates the process to create a payment request, which is typically an ISO based authorization request, and forward it to an acquiring bank or a processor. In the payment request, neither the wallet application nor the TRTSP or merchant or any point of sale terminal, not even acquiring bank, will get access to your actual card number. Therefore, tokenization ensures the strong security measure of your card data and significantly reduces the risk of your card information being stolen. And which is why the token based transactions are known for their high level of security. The moment acquiring bank or acquiring process receives the an authorization request from the point of sale terminal, there's another aspect of now routing. So let's dive into that crucial aspect of routing, because generally what happens when you do a card-based transaction, it is easy for an acquirer and very straightforward for an acquirer to identify the respective card scheme network based on the first 6 or 8 digit of your card number, and that can be used to understand to which particular card network the request has to be routed, right? But in case of tokenization, although it's similar to how it is done in case of the bin routing, but in case of the tokenization, instead of the actual bin ranges, rather than using that, all card networks, they will share their tokenization ranges with the acquiring partners, so that when a token based information or a token based transaction is received by any of the acquiring partner, they can, based on the the token ranges, make a decision to which payment or a card network this request has to be forwarded. The moment an acquiring partner or a bank or processor is able to identify the respective card scheme network, they will assemble the required information and follow the specification of that particular card network and create an ISO packet and send it to the card network. It can be any card network. I'll not take any name here. As I mentioned earlier, the TSP, which is token service provider, nothing but just a part of the card scheme network. It is a different services altogether, or a different system of a card network, which ensures the end-to-end life cycle of a token, whether it is generation, storage, mapping, etc. Right? So the moment transaction reaches to the card scheme network, which eventually means the transaction has also reached till the TSP. So since the TSP is managing all the mapping from a token to a PAN, what they will do is they will retrieve the actual PAN number or a card number from their database and replace the PAN information basically in the ISO message. So they receive a token from acquiring processor or acquiring partner in one of the data element, and they had replaced that token with the actual value of the card number before they forward this ISO authorization request to the respective issuer. In addition to this token and PAN mapping and retrieving the actual PAN number, replacing it in the authorization request, there are several specific actions that are also performed by the card network. The first one, as I said initially, the cryptogram. The cryptogram was generated by TSP and it will be validated by the TSP, because the keys needed to generate and verify this information was only exchanged between these two parties, TRTSP and TSP. Therefore, the moment authorization is received by the TSP, it will, or card scheme network, they will first validate the cryptogram. Second thing they will validate is the predefined PIN. As I said, if a customer or a card holder is entering the mobile PIN while authenticating himself during the tap and pay transaction journey, that particular PIN will be validated by the TSP. The third thing is the ATC, which is the application transaction counter. So there are certain operations or several specific checks that will be validated by the card scheme network or the TSP, and once those authentications, verifications are done and the card, the token is replaced with the actual card number, the same ISO packet which they have received from acquiring partner, after all these modifications, the ISO packet will be sent to issuer with the actual card information. Finally, the issuer has received the transaction from the card network, and when it comes to the issuer, all the things still follow the same path of a traditional card-based transaction. And why I'm saying is because in case of a card-based transaction, generally issuer performs verifications like card verifications and card holder verification, CVV verification, PIN verification, all those things. So in this case also, issuer is still going to perform all those verification, but there is a small catch because there is one difference which I talked about a few minutes ago, that in case of card-based contactless transaction, issuer does receive the EMV data, which is the cryptogram data. At that point in time, the card is actual card, physical card is used. And in most of the scenarios, the EMV data that is passed to the issuer as part of the ISO authorization, that cryptogram is validated by the issuer. Although that's a different story that during the on-behalf services, a card network can also validate. But in most of the scenario, issuer will take that responsibility to verify the cryptogram in case of a card-based transaction. Whereas in case of token-based contactless transaction, as I said, the required keys are exchanged between TRTSP and TSP. So the cryptogram verification, the EMB verification, is generally done by the TSP only. So even if issuer receives that particular information as part of the authorization request, they generally don't do any operation or any verification on top of it. So what it means is, like, apart from this verification, issuer still has to go through all different type of financial checks, monetary checks, or transaction velocities, PIN verifications, CVV verifications, monthly limits, daily limits. So whatever it is, as per the configuration of the issuer, they will perform all other validation on that particular authorization. And there's another thing that I want to talk about is, because when I say this is as good as a card-based transaction, issuer will also receive the token information as part of some other data element, but they may just record that information in their system, but they will not perform in most of the cases any validation on the even on the token information. Let's also cover the PIN requirement of a contactless transaction. Typically for PIN validation, if the transaction amount exceeds a certain limit, only then the PIN is prompted at a point of sale terminal for a customer to enter. For instance, in India, I think the contactless limit is around 5,000 rupees. Any transaction above this limit will be prompted for a PIN for a customer to enter, whereas the below amount, this amount, the customer will not be required to enter any PIN. Similarly, in UAE, I think it's 500 dirham or whatever it is. But just please keep in mind that these limit examples, 5,000 rupees in India and 500 AED, are just for explanation, and you can definitely find the more accurate information or the real figures of these limits on any of the official website. So, but what I'm trying to say is, like, based on these contactless limits defined at the point of sale terminals, the terminal will prompt for a PIN or to bypass a PIN or skip a PIN, and accordingly the user will see the difference behavior in the user journey. In one scenario, the user will be prompted for a PIN, whereas if the amount is below those certain limits, user will not be asked to enter the PIN. Moving towards the final step of this journey is when issuer takes a decision on the authorization and sends a response back to the card scheme network. The moment they receive this response from the card issuer, they will backtrace this connection between card to token. At the time of request, when they were forwarding the request to issuer, they retrieve the card number from the token to card mapping. Whereas when they will receive the response, they will do the reverse of it, and this time they will retrieve the token information from their database, which was mapped against the card number, and place that token information back in the response of the message. And after this replacement of the token is done in the authorization response, they will forward it to the acquirer, and then acquirer will forward it to the merchant or a point of sale terminal. Let me quickly summarize the journey that we have seen successfully for a tap and pay transaction that gets completed into several steps. The first one is, as a card holder, you authenticate yourself on the mobile device and then tap it up on the point of sale terminal. From there, the certain informations like CD, CVM, cryptogram, and the token information is passed to the point of sale. Point of sale collects this information, forms a payment request, forward it to the acquirer or acquiring processor, and after the routing based on the token based routing, acquirer will form again another ISO packet, forward it to TSP. At TSP, they will retrieve the actual card number, send it to issuer. Issuer does all the validation, send it back to scheme. Scheme again retrieve the token, and finally send the response back to the point of sale terminal via acquirer. In addition to it, I would also like to talk about some of the notifications that are exchanged among these parties, like TRTSP, TSP, ITSP, card holder, just to keep them informed about the current status of the transaction and to ensure all of them are in sync at any given time during the transaction processing, so that throughout this journey of tap and pay transaction, they are always in sync. With this final step, we conclude our discussion about tap and pay. However, in one of my upcoming video, I will be hosting a podcast session on tokenization and transaction security with some of my guests on the stage. So please feel free to leave your questions or any thought that you may have so that we can cover those questions in our upcoming podcast. Until then, stay safe, stay connected, and keep smiling. Thank you.